is McKeyla.
Hi, my name is Mimi, and today we'll be talking about the effects of liquid supplements on Ramshorn snail shells. The question that we're trying to answer is, which liquid supplements will strengthen and increase the thickness of Ramshorn snail shells? The three substances that will be used are strontium, magnesium, and silica, and this will be taking place throughout 28 days. We place 7 snails into 4 tanks with heaters, bubbling stones, air pumps, sponge filters, sand, and water. On days 1 through 28, we'll feed 3 algae wafers and soak them in their substances. After that, we'll be measuring using caliper in millimeters on their apertures. On the 28th day, we'll be using a force gauge in newtons to measure the strength of the snail shells. Our results show that there is no significant differences in shell strength and thickness.
An orthopedic, Neil Sharkey worked with the team to improve the effectiveness of strontium on bones which have calcium carbonate materials. Treatments with this increase bone mineral density, and they concluded that these supplements largely increases the bone density, volume, and microarchitecture. Another researcher, Agatha Marnier, and her team researched the effects of strontium on calcium carbonate materials in marine organisms. They found that this plays a key role in biomineralization process, helping to enhance the formation of calcium carbonate.
Based on our previous knowledge, strontium integrates in the shell matrix and improves durability. We hypothesize that liquid strontium will benefit the strength and thickness of Ramshorn snails.
The materials we used are 28 Ramshorn snails, 4 small tanks, glass containers, aquarium heaters, air pumps, bubbling stones, sponge filters, 1 caliper, 1 force gauge, 1 scale, play sand, 16 gallons of bottled water, mini algae wafers, silica, strontium, magnesium, water conditioner, gloves, and disposable droppers.
On the first day, we'll be setting up our tanks with the heaters, bottled water, Ramshorn snails, and condition the tanks. After that, we'll dilute our supplements and place the snails in the concentration for 30 minutes. After that, we'll take out and measure the thickness with a caliper and add the data to our sheets. We'll repeat for 28 days. On the last day, we'll be using a force gauge to press on the snail shells and find their strength. As we can see for our results, they do not pass the ANOVA testing because they're above 0.05. Each of these graphs are for each snail individually, from snails 1 through 7. There's no significant differences between each individual snails. As we can see, these are our results for all the snails combined together. There's no significant differences shown in different liquid supplements differing from one another in shell thickness. As we can see, it's over 0.05. For the strength, there is also no significant differences as it is 0.10256. It is over 0.05.
The ANOVA test results in p-values are greater than 0.05, indicating that there are no significant difference in shell thickness, and the ANOVA test results in p-values are higher than 0.05, indicating that there are no significant difference in shell strength.
For our experiment, we concluded that it does not support our hypothesis as there is no significant variation in shell thickness and strength of Ramshorn snails. They are above 0.05.
We hope that our results will help marine researchers with coral reefs and possibly against the coastline.
These are our references.